Well, good morning, young statisticians. I've prepared a little video here. Wanted to talk to you about this thing called residual plots and what they are and how we're going to use them. This will hopefully help you with part of assignment 9 that you're going to work on today. So what I have is a little situation here. Below is data on a sample of 11 oak trees. The age and cross-sectional diameter of each tree is provided below. So here we have these 11 oak trees, various ages, some quite old, some very young, and different diameters, how far across they are at the trunk. And you'll probably notice that as the older trees tend to be much wider at the trunk, and that's probably really no surprise. But let's kind of look at the data here. So what I've done is I've plotted all the data, and all these blue dots represent the plots, and I've also had the computer find a line of best fit. So it went ahead and drew a line of best fit. It gave me an equation, and it also gave me the what we call the coefficient of determination. We learned this the other day. It's called r squared, and it's 0.893. So that's a pretty good coefficient of determination. About 89% of the variability we see in diameters can be explained by this particular model. So that's pretty good. Well, now over here we have something else called a residual plot. Now, in a residual plot, what you do is you figure out what all the residuals or errors are based on the line of best fit, and you graph them. And so this is a graph of age versus residuals. And so you see here that here's the age along the bottom, and then each of these red dots represents the residual, how much error there is using this line of best fit. And what we use a residual plot for is to ultimately decide, okay, is a line really the best model for this situation? Would a different shape make a better model? And so what the residual plot does, it's really just kind of a scatter plot, kind of rotated a little bit until the line of best fit is kind of level, and you can kind of see, okay, well, there's a whole bunch of points above here, and those kind of correspond to all these points above. That means that the line right in here from anywhere from about age, 8 up to about age 28 or 30, actually the line tends to underpredict the real width of the tree. And for young trees, the line tends to really kind of overpredict. And same thing too with really old trees. We call this curvature, where you've got residuals below, and then you've got a whole group of residuals above the line, and then another group of residuals below the line. We like to see kind of random scattering of residuals both above and below the line. And we really don't have that here. And again, we refer to this as curvature. There's kind of a curvature to the residuals. And that suggests that using a line to describe this relationship between age and diameter is probably not the best model. So let's look at another model that I had the computer construct here. So again, using my spreadsheet, I took the exact same data, but this time instead of trying to fit a line to the data, I had the spreadsheet try to fit a parabola, a quadratic equation to the data. And so it gave me this quadratic equation, and right off the bat you could look at it and go, yeah, that seems like a much better fit for the data. Now, notice the r squared is like 974. Previously, it was like a 0.89, which is pretty good. Well, this is even better. R squared is giving you an idea of kind of how good the model is. The higher your r squared, the better the model. But over here, let's look at the residual plot using this quadratic model. Notice the residual plot. Now I've kind of got, okay, 2 below, 2 above, 1 below, 1 on, 1 above. Below, above. I now have a much more random scattering of the residuals, suggesting that this model is actually a pretty good fit for the situation we have. So again, what you want to look for with residual plots is you'd like to see kind of a random scattering of points. It doesn't have to be perfectly balanced, above and below, but you don't want to see this like large grouping of like, 7 or 8 points all above and then, 5 or 6 points all below. You'd like to see them, spread out a little more. So couple below, couple above, one below, one above, okay, 1 or 2 below, and then we go above. We kind of are continually bouncing back and forth. So once again, we want to, if we see curvature in the residual plot, points below and above and below, that suggests that the model we're using is probably not a good model for this situation. On the other hand, if a residual plot shows random scattering, that suggests that we have a pretty good model for this situation. And you'll be dealing with a few problems on today's assignment where I ask you to interpret the residual plot. So hopefully this helps in your work. Thanks for watching.